Okay, so let us begin. So my name is Duncan Jones. My Twitter handle is down there if you want to get in touch with me. And the subject that I'm going to be discussing today is event sourcing and CQRS on Azure Serverless functions. The way we'll go through this is I will talk through the motivation, which is basically why you would do this in the first place. I'll do a walkthrough of what event sourcing actually is. And then I'll stop for questions at that point because that is kind of quite important, the foundation for how this is all going to work. Then I'll go on to notifications, how the different parts of the system can talk to each other, introducing event grid and so on, and then build up to basically a full system. A couple of caveats before we get started. So the system that I'm describing is a relatively small system. So that's why I've kind of put tree houses rather than power stations. It's kind of, it's for small serverless type systems. And the other caveat is that this is what I'm describing here is an experiment rather than a sort of canonical textbook definition. So, there may be other ways of doing this. There may be other ways of doing this even better than this. So, okay. Motivation. Why are we doing this? I don't know if you have these switches in the States, but basically what that indicates is the cost of leaving something switched on. So we have these immersion heaters for water, and if you leave it switched on, your parents will be very upset with you. So basically, what we're trying to do is create low-cost systems, and one of the best ways of doing that is to reduce any fixed costs, which is leaving servers that have to be switched on all the time. And the second cost that we're basically looking at is, sorry. So the second cost that we're looking at is the cost of over provisioning. So that's a case where we have, too much provision going on. So we're basically, we've got more servers spinned up than the actual demand requires. Okay, so let me break into event sourcing and event streams. So event sourcing is a data storage idea. And the sort of very high level way of looking at it is that we don't store the current state of an entity. What we do is we write down all the history of things that have occurred to that entity. And then we basically, using that, we're able to recreate the state by reading the history. And really the best way I can show that is to actually go through a sort of Hello World worked example. So the Hello World worked example that I'm going to go through here is basically a bank account for like children's pocket money. So if you can imagine, we start out with an empty system like this, and we'll use my nephews and nieces for test data. So Aiden comes in on the first day. First thing he does is he opens his account, and then he has $10 of pocket money, so he deposits that money. Margaret, she also comes in, opens an account, and she also deposits her $10 of pocket money. And finally, Fergal comes in, but being the youngest, he's already spent $5 on the way to the bank, so he deposits his $5. Then later on, Aiden, having seen what Fergal has bought, he takes out $5 in order to buy the same thing. Margaret, having seen how this bank is being run and really not being too pleased with it, she withdraws the $10 and closes her account. And so what you can see there is the way that the data is building up, its history is building up as the events occur. And that's fine for getting data into the system, but then you also have a question of how do we get the data out? Getting the data out is with something which is called a projection. And a projection is really an incredibly simple piece of code that runs through the event stream history. And basically what it's going to do is for each event that it encounters, it's going to have two parts. The first part is, do I care about this event type? And then the second part is, if I do care about this event type, what do I do? So in our example here, if we have a projection that we want to get the balance of the bank account, so what we're going to do is we're going to say, do I care about this event type? So for the first one, the open account event type, we don't care about that at all. It doesn't have any impact on the balance. But a deposit does have an impact. So what we're going to do there is we're going to increase the balance that we're holding by $10. So you can see there that it's gone up to 10. And the withdraw money event, that decreases the balance by the amount in the event there. So we now have $7. And that's our state as at the end of the event stream. Now, what we also do is whenever we return a value from a projection, we also record like the event number, so the index of when that state was true. And that's something that we'll come back to later as to why that's important. So that is, in a nutshell, it's at its highest possible level event sourcing. I'll just give you a couple of sort of rules that make event sourcing make it a lot easier to do. So the first hard and fast rule is that event streams are append only. So you can only add an event to the end of an event stream. There's no deleting and editing of the event stream. And the events themselves are immutable. So once you've written the properties of an event to the event stream, you can't change those properties. So those are the absolute hard and fast rules. The sort of general good practices is that you should name your events as a past tense verb. So, for example, money withdrawn rather than withdraw. It just makes it more obvious that these are things that have happened in the past. And the other thing is that events are only for one entity. So, you know, when you have an event for money withdrawn, it can only apply to one bank account. So that's because everything kind of depends on that idea. What I'll do is I will just quickly see if there are any questions pertaining. Give me half a second to Alt Tab. Any questions on event sourcing as an idea? Oh, all quiet. Well, that is very good. Okay, you're you're a good sight more high up than I'm used to. Okay, let's go through a worked example of how this would work on Azure Functions. There is a URL there if you want to play it along at home. So that is basically a front end to all of this, which I put together in Blazor. It's not a particularly pretty work of art because I'm mainly a back-end developer, but if you can forgive that, then it might help you to go through it. Okay, so let me go through the actual operations, the commands. So the first one is if we're opening a new account. So we have a command to open a new account. We have a constraint there that says that each account number must be unique. And the additional data that we pass into the open account command is a deposit amount and also a beneficiary name, who the account is being opened for. Now, you can see there the constraint, each account number must be unique. That introduces the villain of our piece, which I'm calling the concurrency crocodile. So what this means is, because we are talking about having each event stream has its own unique identifier, and we have a rule that says each account number must be unique, we need to have some kind of control over what would happen if two functions tried to open the same account with the same number at the same time. So let me show you how that would look like as an Azure function. So what we're doing here is we have just a function to open the new account, and that's the URL path at the top there. And we break that down into the various parameters, the bottom of which is an event stream. So the event stream is basically the stream to which the events are going to be appended. And it's uniquely identified by three components. So we have the domain name, the entity type, and the instance. And these can be seen as basically the unique key of every event stream. So in my example here, the domain is bank or banking. The entity type is account, and that really is quite a high level entity type. You know, it's just like you would have your main entities. You wouldn't break it down into sort of quite small components. And then you would also have the instance. So the instance is the unique identifier of that of the new account. So the URL gets passed into that, and then we have our code to actually perform the action. So the first thing it's going to do is it's going to check that the bank account actually exists, or sorry, if the bank account exists, throw an error, because obviously we have we have a rule that says you can't create a new account. Then what we're basically going to do is take the body of the URL that we've passed in and turn that into the event, which is saying we're opening the account. Now we have two constraints here. The first one is basically that's saying, does the account number already exist? But this is sort of an outside of the transaction level. And that's basically saying, okay, we might as well, if we know for a fact that the account number exists as we start the operation, we might as well throw an error. There's no point continuing. However, the second one is, because we could have got past there in two different threads, or however you want to look at it, we need another constraint, which basically says, at the point of appending the event, we have a rule that says the event stream must be new. And that basically would say, okay, if you attempt to write an event to an existing event stream that isn't new, it will throw an error. And that basically allows us to be very confident that there's no way two event streams, two account opening events can happen at the same time. So our rule that the event stream must be new has been obeyed. And then basically all we do is we create an event. So it's a simple POCO class. It's just basically some data. We create that and we append it onto the event stream. And then similarly, if we had set a beneficiary client name, we add another event for that, and so on. And the end result of that is in our table. So this is all the backing storage for this is Azure tables, and in our table we have a row for each event that has been appended. So you can see here, this is our index, and it's saying for the bank account 0, 1, 1, 2, 3, 4, 5, etc. And then below that, there are all the events that have occurred to it in the order in which they occurred. So you can see that the account was opened, money was deposited, the beneficiary was set, and so on. And in the rows there, we have the instance, that's a unique identifier of the bank account, a sequence, which is just an incremental number of the event, and then the event type. So we had account opened there. You can see the extra details of that. For making a deposit, okay, the account must exist, but there's pretty much no other constraint. We don't care what else is going on, what your state of your bank account is when you're making a deposit. That's how banks make so much money. So essentially all we're doing is we're saying if the bank account exists, if the bank account doesn't exist, throw an error. If it does exist, just append the deposited event onto the end. And that's the job done. Getting the data out, again, we have just the rule is that the account number must exist. We also have an additional optional property, which is the as of date. Now, one of the things that's quite powerful about event sourcing is that you can run the event stream to any point in time. So what we're saying here, when we're saying get the balance, if you pass in an as of date, I'm only going to run the projection up to that date and return the balance as at that point in time. So this could be useful for, what was the start of the month, or any system that does that kind of calculation. And again, it's the same idea. We're getting the balance. We pass in the URL, and we have our bank account and account number. But as it's a projection, we also need the class that does the operations of the projection. So that's this one here, and it's just saying the class to pass in is the balance class. And that's just the type of projection that we're going to run. So a look at the projection code itself, you can see, again, as I said, it is really an incredibly simple piece of code. It just has an interface to say what types of events it handles, and then within the handle event instance thing, what are we going to do with that event. So if you look at here, what we're saying with the balance projection is that it handles the money deposited event, and what it does with that is that it increments the current account balance. And then basically, if this is the outer wrapping of that code, we're basically saying if you've got an as of date, run the projection up to the as of date, and then just return whatever the projected balance is. And as I said before, we also return the sequence number of the last event processed. So if you were to run this from Postman, you get an answer like that, just to say the balance is so many dollars as at record 14. So there are 14 events in the event stream as up to the point where we asked for the balance. Okay, so something slightly more difficult then, making a withdrawal. So we have rules, the usual rule that the bank account must exist, but there's an additional rule when making a withdrawal, which is the balance must be greater than or equal to the withdrawal amount. So we don't allow, because these are kids, we don't allow them to go overdrawn. So basically what we're saying is we pass in the withdrawal amount, but we are not allowed to go, the balance is not allowed to go below 0. And this introduces a second concurrency crocodile, because of course, 2 withdrawals could be happening at the same time, or a deposit and a withdrawal, or whatever. So as we're actually doing the operation of seeing whether the balance is greater than or equal to the withdrawal amount, something else could happen. So how do we deal with that? We have both our event stream that we're going to put the new withdrawal event onto, but we also have a projection that's going to give us our account balance. So those are our two parameters there. And what we're doing is we're saying we run the projection to get the current account balance, and then we say if the current account balance is greater than the amount being withdrawn, then you can go ahead and create the withdrawal event. And we're just going to append that to the end of the event stream. But we have our little concurrency protection here, which is basically saying, okay, we're passing in the current sequence number that we got from the balance. So remember, I was talking about that earlier. So we're passing in that. And if the event stream has moved on since that current sequence number, this append will be rejected. So basically, that's our additional protection to say if another withdrawal was happening at exactly the same time, or however you want to see it, we're basically not going to allow this one to continue. And it will throw an error. And what you do with the error, well, that's kind of up to the front end. You could do a retry, because you would get a new fresh balance if you did a retry, or you can throw an error to the front end, or however your business would decide to do it. And this is what it would look like if you ran it and basically you didn't have sufficient money. So that's basically the error message saying insufficient balance. Okay. So another quick Q&A check. Let me just see if anyone has any questions here. Any questions? Oh, what have we got here?
I have a quick question. Was
Sure.
wondering, those concurrency checks and assertions that you pass to the projection or event, is that something you have to code, or they're pre-built?
It is something I have coded, but it is on top of the existing concurrency protection that Azure Tables gives you with. Oh gosh, it's completely skipped my mind. What do you call the? It's built into Azure Tables. The thing to say that a record hasn't been updated. I'll find it again when we get onto the code, and so yeah. So if you could remind me at that point.
Thank you.
No problem. Any other questions? E-tag, good stuff. Gosh. Okay, yes, E-tag is exactly what it uses. So the way that it works behind the scenes is that it updates the index record, which is the one with the record number 000, and it has the E-tag on that. And if that fails, then basically it doesn't do anything else. So it's basically saying that that's kind of a guard record using the E-tag. So yes. Okay, so no other questions on that. Excellent. Okay, so let me talk about, that's basically what we have at the end of this is a fairly simple data storage thing. We've basically reinvented the database, but in not as good a way, but that's a start. The next thing is, what do we do with the data as it's happening? So we also have notifications, and basically notifications happen whenever anything happens to an event stream. So when a new event stream is created, so for example, our new bank account there, we would get a notification for a new entity, and it has domain, instance, entity type, and instance. And then when something is appended onto the end of an event stream, so a new event occurs to an entity, we get a notification for domain, entity type, instance, and also what happened, the sequence number of the event stream, and in addition to that, the sort of payload of the event. So, you can use this for downstream systems that are watching this to say, okay, if you have a system that is interested in, say, withdrawals, it could downstream be looking for event type of withdrawal. So these are then sent out. We also have notifications for projections and classifications. So when I get the balance, it also sends out a notification to say the balance was requested and this was the result. And the reason being that we want to reduce the cost of our systems, and one of the best ways to do that is to make sure it never asks the same question twice. So as a sort of general rule, if someone has done a query and has got the latest balance, and you might have a passively updating screen, you want to have that just basically, just update as this goes on. And the way that these are sent out is through Azure Event Grid. So Azure Event Grid essentially is it is a lot more than what I'm using it for, but it basically is a messaging system that includes routing and all this other sort of functionality. And the way that I'm doing it is with custom topics. So the new entity created, all these kind of things, these are topics that are passed in, and then you use the standard event grid functionality to route those events to whatever listeners there are, and those listeners then would process the events. I would use Azure Functions, but you can also just as well pass it into logic apps or webhooks or however you want to assemble the larger system. And what I would say about Event Grid is an always-on system, so you do have there is going to be a cost to that. It's a particularly low cost because it's a shared system. So basically, you can actually run quite a few systems in the free level of it, but there is always going to be an event grid on behind your system. And the second thing is another crocodile here is that event grid promises at least once delivery. What that means really is that most of the time a message or an event will be processed just once, but sometimes it will be delivered twice, and if you're very unlucky, it'll be delivered 16 times or whatever. So you have to do something in the recipient side to say, okay, have I already received this event before? And the way I do that is to have a GUID associated with each event, and then the recipient has to say, okay, have I received this GUID? You can have a reasonable length of time, so you can say store an hour's worth or a day's worth or however you want to do this, but basically you would have the recipient saying, I have to be coded to deal with the possibility that I may get the same event twice. Okay, and what Event Grid also allows for is filtering. So as I was talking about before, how you could say or you have a recipient that only cares about a specific message type. So what you can do here is you can filter in Event Grid as you set them up. So you can say, okay, this particular one, I only want triggered when there is a new bank account. And that will then, you might have some background function that creates a new welcome pack or whatever, the business magic is, but you basically just hook it up to the new bank account event and you'll end up with, it being triggered auto-magically. The content of the Event Grid message. So what we're doing here is basically saying, you've got your notification ID. I also pass in the domain name, entity type name, etc. So what, from a business context, what did this notification occur to? This is a notification for a projection. So it's saying, okay, the bank account, see whatever the balance projection was run on it. And as at sequence 118, the balance was, 5,048. So that's basically, the message that you're receiving. And what you can do with that is you can basically hook together a whole reactive world. Now, obviously, complexity goes up pretty quickly when you're doing this, but in principle, all the different data elements talking to each other this way is a possible way of creating a system. Now, one of the things that I do is I make sure that there's no privileged communication between the domains. So nothing that the front end can't do, but the back end can do, because it's kind of, it kind of keeps you honest. So what we do is we have our little serverless domains, and we connect them all together with commands and queries, which are fired through Event Grid, and basically notifications, which are fired through Event Grid. Okay, so diving a bit further down, handling a command. So what we're doing here is a command comes into our system via Event Grid, and we are basically then going to handle it, and it could be a multi-step process or something like that. And the way that we do that is with durable functions. So durable functions is an orchestration pattern. It's built into Azure Functions, it's available in Azure Functions, and it's a way of doing multi-step or fan out or anything like that. And the first thing I do is actually create an event stream behind that, so it's kind of tracking the progress of the command, and then basically the durable functions will then start executing the command. So perform any validations. This might be, for example, is the person who has issued the command authorized to do this? Is the system in a state to deal with the command, etc. So we do all of that up front, and then do any actual action that is required from the events. So this is updating our data. So that occurs after our validations there. And so to give you an example, so the trigger coming in is a standard orchestration. So we were saying, okay, I've started my command. Now this particular command here is we're going to do a command for a lot of entities. So applying interest to all the accounts, that are going to say, okay, all the open accounts we want to run the apply interest thing for. So that then requires a fan out orchestration. So what we're doing then is we're saying we do I get the collection of all the account numbers, and then in parallel call the activities, the pay interest activity. And the pay interest activity just does, the one account. And basically durable functions will handle sending that all out and then waiting for it all to complete. So the await there will then complete then the command will finish. The query is done pretty much the same way. So a query also comes in as an event grid message, and it also triggers a durable function. There's slightly more in the query message. So what we're also doing, as well as the query name and so on, we also pass in a return address. So return address could be a webhook or a storage location or whatever. And we're saying, when you have completed the process of running this query, put the data in whatever this return address is. And the process again is exactly the same. We create an event stream behind the scenes to actually track the operation of the query. We do our validations to make sure it's a sensible query to run, and then we run our projections. And again, we're going to use a fan out thing here, because the projections we might want to run the query against multiple event streams at the same time, or we might have to do multiple different event stream types at the same time. So we basically are using durable functions to do the fan out side of things, and then it will return back onto the query event stream the results. And then when we've got them all back, we then have the results that we can send out to our to our whatever return address that we passed in. And the orchestrator looks a bit like this. Basically, we're saying we have our query event stream. We're appending a projection request to the event stream for every projection that we're going to need. We then run the projections. You just see that, and then basically once they've all finished, it all comes back to the query results, and we then send them out to whoever we have added as our return address. So that is how it all looks. What I'll do is I'll go back to Q&A now, and then what I'm hoping is we will be able to basically go wherever you're guiding me with your questions. So are there any questions on this as it stands? Or indeed, have I baffled everyone into a stupor? Oh, okay. Okay, let's look at the real world. I'm going to have to stop sharing and then change to sharing my screen. Share desktop. And so can everyone see that? You should have my account A001 in the top screen there.
Yes.
Okay, perfect. Thank you. Whew. Okay, so this is, as I said, this is the rather ugly but nonetheless functional front end that I did using Blazor. And basically, there is no database behind this. All of this is done through Azure Function calls, and they themselves go to the storage behind and uses the event sourcing. So what I'll do is I will start with getting the balance, and these call the same commands that I was showing you earlier. So we have the as of date. If it's today, then it will get the whole balance, or if I set it to the past, it'll get the balance as at that point in time. So I'll just fire that off. And it's back there saying, okay, the balance as of the 16th of January was $12,000. You can also see at the bottom here, I return the sequence number, and that's just, to show that it is actually doing, returning up to a point in time. So if I go back to middle of last month, get the balance as of that, and it goes down to sequence number 1617. So you can see that basically with event sourcing, all parts of the data are equally accessible. The history is, can be run to any point in time, relatively straightforward. Making deposit, again, it's I'm just putting in the property. Let's do cash at desk, and submitting that. Now, because we don't have to run any projections for this, we don't have a sequence number, because basically it doesn't matter at all. The other events on the system, it doesn't matter at all whether they have, how many they are or whatever. We just deposit in the money. For a withdrawal, however, it is going to matter. So let's do a withdrawal of one that will be allowed. So we submit that. Submit that. And that basically, as well as returning the sequence number, it returns a new balance because we had that information available. And I also have added the possibility of overdraft levels. So because I have to run a projection for that as well, again, we have the overdraft projection result there. And finally, obviously, we are also able to set an overdraft limit. Now, let's see what that has done. So the Storage Explorer here, you can see the rogue key of all the different events that have happened. What I'm going to do is I'm going to just create a one in Postman, just specifically for this, so that we can, prove that it has worked or not. So this is my new account number. There. Oops, it's not allowing me to select it for some reason. Anyway, philnet 001. So I have lost my mouse pointer. Okay, philnet 001. So if I send that, this is exactly the same as the front end is going to do, but it's sending it to that post address there. Sending request, okay. There's a very good chance that demoitis will strike in. Oh no, okay. So it did create the account, and that is it was not in error. Now, if I go back to the table, and if I filter by this new account number and get rid of the row number, oh, it has not worked. Okay, bit of demoitis has occurred there. I'm not really sure what the story is. Oh, I missed the one. Okay, it is human error. Right. Phew. Okay, so what we have there is our first row is our index record, just says what the domain name, entity type, and instance key are. And then the remaining rows there are the events that occurred. So we actually had 3 events as a result of that account opening. There's an account open event, we deposited an initial amount, and we set the beneficiary, and you can see all the data in there. Like that. And we could do various other operations, and they would appear on there as well. What you can also see in here is the notifications occurring, this crazy pattern here. Basically, this is all the stuff that we did just now. And you can these are the event grid notifications that have occurred. So if you want to see, for example, the balance projections that we ran, you can see that we've done, that's quite a long time. Let's do 1 hour. So you can see that we did 5 balance projections in the last hour or so, and that's basically the way that the notifications work. So, any questions on that? Is it all relatively hanging together? Take that as a yes. Why not? Okay, so the real test of it is to run something really rather large. So what I'm going to do here is I have 20,000 bank accounts in this test system. What I'm going to do is apply interest for all of them, and then we can switch over to the monitor and watch all the craziness happening. And you can see how basically Azure Function scales quite rapidly to do all this work, and how it all is basically working. So I will send that. Hopefully it will come back with a 204. It did. Okay, so now if I switch back to my to that and go to the function app. So you see the execution count start to creep up. It's a little bit slow, this, because it's behind our okay. It'll start going up, but as I say, it's a bit behind our what's actually happening. So what I might do is I might come back to that later. Okay, so that is basically it, as in that is the system in a nutshell. So is there any part of it that you think we could do with a deep dive into, or more explanation, or how are you getting on with all that? Is there anything that you would like Yes, go ahead.
Yeah, I have a quick question, and this is the first time I'm seeing this, so I'll play the newbie card here. So hopefully it's not a dumb question, but I was wondering with these tables, like how did they get created? Like you showed the tables of account, like because the
Yes.
things with event sourcing I've seen, or from what I remember, is your event kind of built in the events or storage. So yeah, I wasn't sure the
Yeah, no, that's fine. So the way that, again, so this is code that I've written myself, but it's only a thin wrapper on the Azure stuff. But what I do is, you know how I was talking about there being a um, a domain type and then an entity type, so bank and account. So the domain type points to your storage location. So that would be an Azure storage bucket or whatever you call it. And then the entity type creates a table. So if I was to go back to my Azure there and go to storage, boom, 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 storage, there we go. And you have the storage explorer here. So these tables, so you see how it's account 00 bank. So that is a table that was specifically created for the bank domain and for the account entity.
okay.
And you can see there what's stored in here is all the different bank accounts in row key order. But you can see I also have tables for other things that are going on. So I talked about how when I create a new query or a new command, they also are backed by an event stream. So this could be the applying interest command. So again, it's a bank command, and that's its what is the command name. So you can see the command name there is apply accrued interest. And then basically the steps that occurred in doing that are each recorded as a row. And similarly for a query, getting the available balance, we are saying, okay, the query unique identifier, and then what that is doing is saying, firing off requests to get the balance for a bunch of different bank accounts. So in this particular case, the query is saying, are they in credit or not? So account number A, whatever, A001, it requests to see, are you in balance? And the answer comes back, yes, it is in credit. Then it does the same for B. The answer comes back, B is in credit. But you can see how in event sourcing things can happen, at the same time. So what's happened is here is I've requested to see if B is in balance, and then after that, the request to see if this next one is in balance also triggers, and the return actually comes back sometime later. So this is all able to happen entirely in parallel.
Mm-hmm. Thank you.
No worries. Okay, anything else? Anyone else?
Oh, I'm also going to ask then about snapshots for when you store data. So if your event storage gets really huge, is there anything like snapshots that can take the current state and keep it and delete your old events?
So what I would say as a general principle is don't delete old events ever. Now that is controversial. I mean, the people who pay for the storage probably think otherwise, but basically it's probably better not to delete old events. But when you run a projection, you can also pass in the starting point. So let's say I was running my balance projection. I can also say, okay, starting from sequence 1400 and a balance of $900, run from there onwards. So what that means is you can have a snapshot of the state for each projection. But I don't store that in the stream itself. Just personal preference, I actually have that stored elsewhere. And basically what you would have is it's basically a JSON file. You pass that in and you say, this is my starting point. Please run the projection from there. So that's basically how that works. Does that make sense? I can show you the code as well if you want to.
Yeah,
I'm
thanks.
not really sure how well how understandable it is, but I hope it's okay. So if I go down to the common library, and what am I running? I am running event sourcing, implementation, projection processor. So projection processor is basically just saying, if you pass in the name of the stream, I will run, and the name of the projection, I will run it and give you results back. And what you can do here is you can pass in the existing state here. So I apologize, my mouse is very slow at the moment, but okay, so this is, the projection state that you previously recorded. You can pass that in and you can say, okay, process the projection from that state, and it basically will use the index stored in that state, the sequence number, and it will start from there. So it'll say, I want to run from starting point number, say row 300 onwards, and then if you pass in an amount, a sort of a starting amount, and then row 300, it'll just do the rest of the processing to date. So that's how snapshots, I suppose you could call them. I just call them saved values or whatever, but that's how that would run. And that's also why every projection passes back the sequence number.
Okay, thank you.
No worries. So I have URLs for this, for the source code and the test thing. Let me just, so this is the URL for the test app. If you want to play around with it and see if you can break it. That's that there. I have tested it with a small number of concurrent users, and I feel it should be okay, but that's not really good enough. So if you are able to find anything where it falls over, I'd be interested to know. And the other thing is, where's all the source code for this? So it is all in this GitHub. GitHub project. There is documentation, etc., to show how that works. But as I say, the main thing about it is that it's more showing the power of the various Azure systems that underlie it, so Event Grid and Azure Tables and functions and durable functions, than specifically that code itself. That code is really sort of a bit of a wrapper around it. Okay, any other questions? Any other comments, feedback, anything? Okay, thank you very much. My Twitter handle, if something does come back to you at any stage, is that. And yeah, thank you very much for lending me your time. Cheers.